Okay, let's look at the homework 12, number 4, part A. Alright, so we have equation of the ellipsoid, and we want to rewrite it, the equation, so that it's a relative to principal axis, so nice and straight. Right, so let's do that. So we want to look at the matrix. So this guy can be rewritten as into a matrix equation. Right, so this is going to be written as, right, you have x, y, and z. Right, then the matrix is going to be, right, so coefficient of x squared goes here. Right, coefficient of y squared goes here. And the coefficient of z squared goes here, right? So you have an x, y, so 1/2 of 4 would be 2. So 2 goes here and there. And x and z, so it's going to be 1 and 3, so it's going to be 1/2 of that is 1 here and a 1 there, right? And it's a -2, so y and z, so it's going to be 1/2 of that is -1 here and a -1 there. Right, then you have x, y, and z. Right, so you can double check that you multiply out, you get exactly the same equation. So this is equal to 12. Right, then we are trying to find the eigenvalues of this matrix right here. Right, so let's find that. So we want to find eigenvalue. So we put the 1 minus lambda and a 2, 1. And you have a 2. Then you have 1 minus lambda again. And a -1. Right? 1, -1. And you have a 1 minus lambda. Right, we want this determinant to be 0. Right. Alright, so let's do a little bit of a trick here. Since you have a -1 and a +1, I'm going to add the first row to the second row. Right, so you're going to get, right, so you have a 1 minus lambda, right, 2, 1. Right, so let's say 2 plus 1 minus lambda would be 3 minus lambda, right? And this guy, actually we're adding, so we have 2 plus 1 minus lambda is 3 minus lambda, right? So 1 plus -1 is 0, so it's kind of nice. All right, then you have 1, -1, 1 minus lambda. Right, so since second row, you can factor out the 3 minus lambda, so we can just do that. So we have 3 minus lambda, it's factored out. All right, then you have 1 minus lambda, 2, 1. And so this is going to be just 1 and a 1, 0. Since quantity 3 minus lambda is factored out. So you get the 1, -1, 1 minus lambda here. All right. So we have that. All right. Then maybe since we already got the 0, 1, and maybe we can turn this into 0 by doing another, this is going to be a column operation. Why don't I subtract column 2 from column 1? Right, so let's do that. So you're going to get, right, so 1 minus lambda minus 2 is -1 minus lambda. Right, 1 minus 1 is 0, which is what we wanted. And a 1 minus -1, so it's going to be 2 here. Right, then you have, oh, actually I forgot to put the 3 minus lambda there, so why don't I put it at the end. So you have 3 minus lambda. Sorry about that. All right, then rest is the same. So you have a 2, 1, negative 1, 1, 0, 1 minus lambda. Right? So I'm gonna go down here. Right? So we still have 3 minus lambda, so I'll keep that in there. All right? Then here, so we have, so that's going to be a, let's see, positive, negative, positive. So positive 1, then you can just strike out the second row and strike out the second column. So you have a submatrix, which is going to be negative 1 minus lambda. And you have 1 here, and a 2 here, and a 1 minus lambda, right? And that's that. And we can compute. So this is going to be, right, 3 minus lambda, right? So that you multiply it out. Let's see, this times that gives you, let's see, lambda squared minus, so it's lambda minus 1 and then lambda plus 1. Okay, minus 1 minus 1 times 2 is 2. All right. So what you get is really just lambda squared minus 3. All right. So lambda squared minus 3. So we can further factor it out. Right, so you have a 3 minus lambda, right? So this is lambda square minus 3, so it's going to be lambda plus square root of 3 times lambda minus square root of 3, right? So this will give you 3 eigenvalues, right? So lambda 1, that's 3. And lambda 2, negative square root of 3. And the lambda 3 will be positive square root of 3. Right? Then you can use these eigenvectors to write the equation relative to principal axis. Right? I'll let you finish that up. Right? That's it. I hope that this was clear.